Now moving on to the next question, which is 9.2. Now here we need to determine sizes given reasons, right? Now let me give you a tip with regards to these type of questions, and I'm gonna try and write them on the side. So first step, you're gonna try and see if you could use theorems. Yeah, right. Remember your circle theorems. Try to see if you could use theorems to find your angles. Basically, whatever your angle that they're asking you to find. Now, if you can't use theorems, right? Maybe let's say that angle, you can't be able to use any theorem in order to find it. Ask yourself, what type of a shape is your angle at? Right? Ask yourself what type of a shape is your angle at, right? After you've identified the shape, ask yourself what are the properties of that shape, right? From there, after you have identified the properties, try to use those properties to use the properties to solve for your angle. So first, your first step, it will be to try to use your circle theorems to find that angle. Now, if you can use circle theorems, ask yourself what type of shape it's your angle is at, right? Now, after you've identified the shape, ask yourself what are the properties of that shape. Then you use those properties to solve for your angle. All right. Now, let us try and answer these questions that we're given here. So in the diagram below, df is a diameter. Now, every time whenever I'm told about a diameter, what comes into my mind, it is theorem 3. Basically, angle in a semicircle. Remember, your diameter subtends or it creates a perpendicular angle, right? So if I were to draw it here, so this is my df, which is the diameter. Now, as a result, the angle that it would create the whole of angle E, right? So let me just try and erase here. So based on this, I know that this whole of angle E is going to be perpendicular. E1 plus E2 plus E3 is going to be equals to 90 degrees, right? Now, also, okay, now the center of the circle is O. Now chord EG intersects DF at H. Okay, this is chord GE. Now also we are given that, okay, DF is perpendicular to EG. Now we are also given this angle G as 55 degrees. Now, first step here, or the first question that we are asked, is that we need to find the angle D. Now we need to find the angle D. All right. Now, most of the time with my first questions, I'm going to try to see how can I use this angle that I'm given in order to identify my angle that I'm trying to look for, right? So basically this angle right over here. Now, first, I'm going to see if I could use any theorems. Now, how can I interlink the two? Now, note the shape that both of these angles, they create, right? So I want you to note something. Let me just draw it here. Now, can you see that this is a butterfly? And remember, what theorem do we use with regards to butterflies, right? Your theorem 4, basically angles in the same segment, right? So angle D, it's in the same segment with angle G, right? So here, I'm going to write my answers on the sides. For A, angle D is going to be equals to angle G. Why is that? Because these are angles in the same segment. In the same segment, right? Now, as a result, my angle D is going to be equals to 55 degrees. So let me highlight it there on my shape. So I know that this angle here is going to be 55, my angle D, right, which is equals to that. Now, O2. Now, every time whenever I am given or I am asked to find an angle at center, so the first thing that I'm going to use, I'm going to try and see if I could use my theorem 2, whereby my angle at center is twice the angle at circumference. So every time whenever they're asking you to solve your angle at center, 90% of the time, not all the time, right? 90% of the time, you're going to make use of your theorem 2. So I'm going to try and identify my shape. Remember this shape, right? Basically, the theorem we've proved before, right? This angle is going to be twice that angle. So I'm going to try and identify that shape. So here, I have my O2. Now, if I were to try to identify or draw that shape, it would be like that. Now, can you see the shape? Right. And as a result, this O2 is going to be twice my angle G in this instance. All right. So to answer this question, angle O2, it's going to be 2 multiplied to angle G, right? And why is that? Angle at center, it's twice the angle at circumference. All right. As a result, my O2, it's going to be equals to 2 multiplied by 55, which is going to be 110 degrees, right? So let me just make note of that on my sketch. So this is 110 degrees. Now, E2, right? So let me see if I could find E2. Now, E2 here, let me see which theorem can I use to find E2. Okay, I can't see angles in the same segment. So, okay, basically for E2, let me erase everything that is happening there on E. But remember, the whole of E is equals to 90 degrees, right? Now, with regards to E2, if you note, okay, I can't be able to identify a theorem that I could use in this instance, right? So basically here, I'm gonna see, okay, first I'm gonna use my second step. What is the shape is my what is the kind of shape my angle is at? Now, if you note this, I'm gonna try and separate the triangle that is at. So it's triangle, so I'm drawing it here. So this is E at the top, this is H, this is O, and this is O1, this is H2, this is E2. Now, I want you to note something, right? The kind of triangle this would be, it's a right angle triangle. Why is that? H2 would also be equals to 90. And why, right? So my first point, I'm going to say, okay, H2 is going to be equals to 90 degrees. Angles on a straight line. Because if you add H3 as well as H2, you should get 180 degrees, right? Angles on a straight line. Now, if H2 is equals to 90, can you be able to find O1 now that you have O2? Yes, right? You can be able to find O1. So O1 is basically going to be equals to 180 minus 110. And the reason would be the same reason, angles on a straight line. So as a result, so this is for O1. My O1 is going to be equals to 70 degrees. Now, this is a triangle. To be specific, a right angle triangle. And one of the properties of this right angle triangle is that sum of angles inside of it, they're going to be equals to 180 degrees, right? So this is the appropriate property that we're going to make use of in this instance. So now, to solve for my E2, right, so O1, it is 70 degrees. And now to solve for my E2, it will be equals to 180 minus 90 minus 70. And my reason would be sum of angles in a triangle. As a result, my angle E2, it will be equals to 20 degrees, right? So my E2, it will be equals to 20, right? So this is where I did my workings, by the way. So my E2 is going to be equals to 20 degrees, right? Now let me try and erase here and try to solve for the next question. So E2, 20 degrees. Now find E3, right? So now lastly, we need to solve for E3. Now remember before, I said this whole angle E is going to be 90. How can I find E3? So first I'm going to start by mentioning that point. Angle E as a whole is going to be 90 degrees. Why? Angle in a semicircle. Now, I have one of the angles here, which is angle E2. Now, if I could find E1, can you agree that it would be easier for me to find E3, right? Can you be able to find E1? Yes, right? Look at the triangle whereby your E1 is situated. This is the triangle. And inside that triangle, right, you have angle D, which is 55. You have angle H3, which is 90. So you can solve for E1, right? So as a result, I'm going to solve for E1 here. So I'm going to say, all right, E1 is going to be equals to 180 minus 90 minus 55, right? Which are these angles in triangle DHE, right? So as a result, my E1 is going to be equals to 35 degrees. So this angle here, it's 35. Now, remember, all these angles combined, E1, E2, and E3, they need to add up to 90 degrees, right? So as a result, I'm going to write that statement here. So E1 plus E2 plus E3, they're going to add up to 90 degrees. And we said the reason here, right, above. These are angles in a semicircle. So now, substituting the values that I have, so my E1 is 35 plus E2, which is 20 degrees, and I'm solving for my E3. And all of this is equals to 90. So as a result, my E3, it will be equals to 90 minus 35 minus 20. And punching this into my calculator, my E3 should be equals to 35 degrees. So now my E1, I said it's going to be 35. Same applies to my E3. It's going to be 35. So this here, now let me see what the next question is requiring for me. Right, so let me just put on this highlighter. Determine the length of OH, right? So let me see where's my OH. So my OH is this line. Now, every time whenever I see, can you see that OH, right? It's line from center. So OD basically is my radii, right? So every time whenever I see a line from center to circumference, which is a radii, right? Passing through a chord. Now remember GE, it's a chord, right? So let me highlight GE. This line right over here, it's a chord. And OD, it's my radii. Remember, if your radii, right? So can you agree that as a result, your H2 is also going to be 90 degrees, right? So this angle here, it's going to be 90 because H3 is 90 degrees. So as a result, whenever a line from center to circumference, basically my radii, right, passes through my chord at 90 degrees, this is going to bisect my chord into two equal halves. So as a result, this side is going to be equals to this side. And this is the converse of theorem 1, right? So basically, because I could see that OD is my radius and GE it's my chord, and as a result, because OD passes through my chord at 90 degrees, it simply means that it's gonna bisect my chord into two equal halves in accordance to the theorem or the converse of theorem 1, right? So now I'm gonna first start by mentioning that point, right, before anything else. So I'm gonna say, all right, GH is gonna be equals to HE, which is in my chord, GH is gonna be equals to HE, and my reason is line from center, it's perpendicular to chord. Right? And I've just highlighted that. So now what is it that they want me to find? So, okay, if the diameter of the circle is 10 units, now remember, our diameter is this line from D to F. If it's 10 units, remember, this O is my center. So as a result, DO, right, OD is going to be equals to OF. Why? Because both these are radii. Right? Both of these are radii. And if my diameter is 10 centimeters, it simply means that both of these lines are going to be equals to 5 centimeters. So as a result, I know that, okay, the line from O to D, it's 5 centimeters. I also know that this line here is 5 centimeters, right? Now, also, I have another radius. What is my other radius? My radii, it's OE, because this is line from center to circumference, right? So let me try and erase these values here, the angles that I have here. So the distance from O to E it's also going to be 5 centimeters, right? So I know that my distance from O to E is 5 centimeters in accordance to the information I was given. Now, and GE is 9,4 units. Now remember, GE is our chord, this line. And we said this chord is going to be bisected into two equal lines. Hence, we said GH is going to be equals to HE, meaning that these lines, GH and HE, to find each of them, we're going to take 9,4 and we're going to divide it by 2, right? As a result, if we divide that by 2, each line is going to be equals to 4,7. Now, what is the length that we're trying to determine? OH. Now, let me try and see what kind of a shape my OH is at. Now, this is my OH. So let me try and separate that triangle here on the side, right? Now, this is E, this is H, this is O. And I'm trying to determine the length from O to H. Now, this here is at 90 degrees. This is a right angle triangle. Now, what length do I have so far? I said the length from O to E is going to be 5 centimeters. Because remember, if my diameter is 10, right, it simply means that DF, if it's 10, it simply means that DO is going to be 5, OF is also going to be 5 because these lines are equal, right? So as a result, remember your radii are equal to one another. So this OE, I've determined it as 5 centimeters. Now, remember HE, which is this line here, I said this is going to be equals to this line, which is HG. Because of why? Line from center is perpendicular to chord. As a result, my HE is 4,7. Now, I'm trying to find OH. This is my right angle triangle. What properties of these right angle triangle can I use to find OH? Remember, every time whenever you determine a line in a right angle triangle, you would need to make use of your theorem of Pythagoras. So this line that is opposite to my 90 degrees, it will be my hypotenuse, right? So this way, it will be my opposite. This would be my adjacent in this instance. So now I'm going to say, okay, r squared is equals to x squared plus y squared. Now I'm trying to solve for this, my y squared in this instance. So I'm going to make this to be in terms of y squared. So y squared is equals to, so I'm going to take the x to the other side, r squared minus x squared. Now doing so, let me write this here. I'm going to continue here on the other side. Right? My y squared, which is what I'm trying to determine, is equals to my r, which is 5 squared, plus, or rather minus. So here it's minus my x squared, which is 4,7 squared. And remember, I'm solving for y, not y squared. So I'm going to square root both sides. As a result, this squared is going to cancel out with the square root. Here, you're simply just going to punch everything to your calculator to find your value of y. And doing so, your y value should be equals to 1,71 units. And this would be your final answer. This is the length of OH, right? So your OH, it's 1,71 units. Remember to show those workings on your answer sheet. And that will be all for this question. In the next video, we're going to be continuing with these Euclidean geometry questions. Make sure you stay tuned. Thank you.